Our lesson is divided into three parts. First, we will define what a matrix is. Second is discuss the different operations we can apply on matrices. And lastly, we identify special types of matrices. So for the first part, what is a matrix? A matrix is simply a rectangular array of numbers. We label a matrix by any capital letter. So here we have the capital letter A. The array of numbers is enclosed by a square bracket. Sometimes it is enclosed by open and closed parentheses, but in our class, let us just stick with square brackets. Each entry is denoted by Aij. For example, we have A11, A21, and A12. We use the small letter A because it is the corresponding small letter of the matrix capital A. The entry Aij is often called the ij entry of A. That means the entry in the ith row and jth column of A. For instance, A21 is the entry on the second row of A and the first column of A. In comparison with A12, this is the entry on the first row and second column of A. We also write the matrix A as like this, as a shorter notation. The first number I in the subscript of Aij gives the row number. So the entries A11, A12 until A1n lies on the first row, while the entries A21, A22 until A2n lies on the second row of A. On the other hand, the second number, j, in the subscript of Aij gives the column number. So the entries A11, A21 until AM1 lies on the first column of A, while the entries A12, A22 until AM2 lies on the second column. Note that our matrix A has m rows and n columns. And so we say that A is an m by n matrix, or the size of the matrix A is m by n. M by n, that is number of rows by number of columns. Before we proceed, let us take this example. Let us consider this matrix M, 1, 0, 3 to negative 1, 4. The matrix M has 2 rows and 3 columns. Thus, M is a 2 by 3 matrix. Now let us find for the 1, 3, and 2, 2 entries of M. The 1, 3 entry of M lies on the first row and third column, that is 3. And the 2, 2 entry lies on the second row and second column, that is negative 1. Now, what if our matrix have the same number of rows and same number of columns? Then we say that our matrix is a square matrix of order n, where n is the number of rows or the number of columns. To specify that our matrix is a square matrix, we write A as A sub n. And we say that the entries A11, A22 until ANN are entries on the main diagonal of A. As an example, let's take this matrix M, 0, negative 3, negative 1, 2. This matrix has 2 rows and 2 columns, so it is a 2 by 2 matrix. And thus we say that M is a square matrix of order 2. And we can write M as M sub 2. Also, the entries on the main diagonal are 0 and 2. Now let's talk about equality of matrices. We say that two matrices are equal if they agree entry by entry. So if we have two matrices Aij and matrix whose entries are Bij, then A is equal to B if and only if Aij is equal to Bij for any I and j. Let's have this example. Suppose we have these two matrices A and B. They have equal first and second rows. But note that B has a third row, unlike the matrix A. Therefore, A is not equal to B. What if we have this matrix C? The matrices A and C are almost equal except for the 1, 2, and 3. A12 is equal to 1 and C12 is equal to -1. So A is also not equal to C.